This is homework set 38 on common and natural logarithms. Question 1 asks us to find the following values here of these logarithms, and notice there's no base, so these are common logarithms, log base 10. So on our calculator, here's what we're going to do. Say for part A, we're going to press the key on the left side that says log. When you do that, here's what you get. You get the log parentheses. Now type in 132. Use right above the 8 or 9, you'll see the parentheses. Type in 132. Press enter. And I got this. This is equal to 2.1206. Now the instructions say to round to at least 2 decimal places. I like to round logarithms to 4, so I'm going out here. And for this problem, let's give some meaning to this. Here's what we're saying. We're saying that the logarithm, or the log, base 10 of 132 is equal to 2.1206. Now, here's what this means. We know that logarithms are exponents. So the exponent, 2.1206, goes on the base 10. So we're saying that 10 to the 2.1206 is going to be about equal to 132. And we're just saying about because we rounded this off. You know, if it just keeps on going, but we rounded it off. So this is approximate. Now part B, instead of 132, divide it by 10, we'll get the log of 13.2, and this is going to equal 1.1206. I'm going to put those numbers in right up here. So part A is 2.1206. B, now if you divide the 132 by 10, we're now down here to 1.1206. So you see what's happened? It has just changed in that 10's position, in that 1's position. Part C. In part C, type in, all right, this is part C, log of, now in this case, it's the log of, instead of dividing by 10, we're going to multiply by 10. Now, if you divide by 10, you get 1.12. What do you think is going to happen if we multiply by 10? Well, if we multiply that by 10, we're going to get a log of 1320. This is going to be 3.1206. Is that what you guessed? 3.1206. Okay, now, in this part here, D, we're going to divide by, what are we dividing by? 10, 100, 1,000, 10,000. All right, so now we're going to get that this is, let me get this here. This is going to be part D. This is the log of 0.0132, and this turns out to be negative 1.879. Part E, we're going to multiply now by 1,000. So we are going to get the log of 132 times 10, times 10 times 100, multiplied by 100 there, or 1,000. We're going to get, what did I get here? I got 4.1206. And that doesn't surprise me because back here, when I multiplied by 10, I got the 3, and now I'm multiplying by 100, so I'm going to get the 4. All right, so to finish it off, this will be 4.1206, and this one here was negative 1.879. Good enough. Question 3 asks us to find the value of x in both of these statements here. Now, let's do part A, and then we'll see what part B is going to look like. Part A says this, log, now there's no base. I'm going to write the base. Log base 10 of x is equal to 2.2148438. Now, what we're looking for is the value of x. Log base 10 of what number gives us this? Well, I can do that if I rewrite this in exponential form. And I know this, that logarithms are exponents. So the exponent is this one, 2.21, so on, goes on a base. So it means 10 to the 0.2148438. that's equal to x. Now, we're going to do a couple of these. So on your calculator, I want you to do this. Press the second key, right, the top blue one, right? This is in blue, right near the top. And then what you're going to do is press second, and then you're going to press this key, LOG. Because right above the LOG is 10 to the x. So second log will give us 10 to the x. That's exactly what we want here, 10 to something. All right, so now when you do that, and now what comes up on your calculator is 10 to the x. All right, now it's asking you to type something in. So actually, what's coming up on your calculator is this. All right, now type in that x value. It is, so just type in 2.2148438. So I got 163 point, and then all nines here. The directions up at the top, up here, say to round to the nearest whole number. Now the nearest whole number is going to be round up to the 64, so 164. Part B is similar, but now what we're doing is we're finding the log of not 2.214 and so on, but 4.2148438. Now, the difference is the first one was 2 point something, second one is 4 point something. Can you guess what it's going to be? So I pressed that second key and then the log key, and that gave me the 10 to the x. So I got 10, and then my cursor is up here. So I typed in that 4.2148438, and that gave me 16399 point, and then all those nines. Now, if I round this up, this is going to be okay. This goes up, this one goes up, this one goes up, so I get 16400. Question 3, this is similar to question 2, but instead of log base 10, we've got the natural log, which is log base e. So in part A, we're looking at this. The natural log of x is equal to -5. But when I see natural log, what I'm thinking in my head is this. Log base e of x is equal to -5. Now what this means is that e to the -5, that's equal to x, and this is what we're looking for, right? We're looking for this. So on the calculator, you're going to type in or press second, right? That's the blue key. And then instead of LOG, you're going to press the LN key, because right above that is the e to the x key. And when you do that, at least on my calculator, I got e, and then I got a box up here. It's waiting for me to input. And when I put in -5, now be careful. This is negative. This is on that key at the very bottom right. It's the negative key. This is not the minus key. All right, so when I did that, I got this number here. I got 0.067377947. I'm not going to carry that all the way out. Directions say to round to at least 2 decimal places. You know, when I do logarithms, I just like to carry them out to 4. So I'm going to 006. Now, this is a 7. I'm going to go out there. This is a 3 below 5. So I'm just going to drop it. So I'm going to write this as 7. Part B, now we want the natural log of x is equaling 3. All right, so this is going to be, right, the second key, ln, that gives us the e to the x, so you get e to a box, and now you're going to type in 3. So now we're looking at this. All right, so what do we get here? Well, I am showing 20.0855 and so on. So I'm going to take this out. Well, that so on, there's a 3 out here. All right, I'm going to write this as 20.0855. And this, of course, means that e to the third, right? It means, I'm up here, e, right? Actually, what does this mean? Like look back over here. Let's look at this one. I already have it written out. The logarithm is the exponent. So e to the -5 is this number right here. So this one means this one down here means e to the negative 5 is about 0.0067. In question 4, we're not computing anything. We're just using the properties of logarithms to expand this expression right here. Now, first up, let's just do it in steps here. I've got a multiplication in here, right? I've got a product. This is a product. So products turn into sum. So this is natural log of 10 plus the natural log of e to the 4t. But now, this part right here, this is the natural log of e to the 4t, which means this. Let's just see it happen. Log of e to the 4t. So we're asking, what power would you raise e to get e to the 4t? All right, we're kind of looking at this. E to what power would you get e to the 4t? Well, 4t, of course. So what happens here is that the logarithm undoes the exponential. These are inverse functions. The logarithm undoes the exponential as long as they're the same base. So as long as I have the same base, I can just write the exponent. So what I get here is this. The natural log of 10 plus 4t. Question 5 asks us to use the properties of logarithms to expand this expression right here. So first of all, I've got that negative. Now that negative is outside the log, so it's going to be negative. Now let's just do this. This inside, you can see a multiplication. So that means an addition is coming. So this is going to be the log of 7.3 plus the log, you know what, I'm going to write base 10s here, plus the log, base 10 of 10 to the negative 6. So let's distribute that negative sign first up here. So we'll get negative the log of base 10 of 7.3 minus the log base 10 of, all right, 10 to the negative 6. Let's just look at this part right here. See this term here? I've got a base, and those bases match. So when the bases match, you just get the exponent, right? There's a property that says this. If you have the log base b of, say, b to the x, you just get, well, here's what you're asking. What exponent would you put on that base to get b to the x, right? So you're asking this. B to what is b to the x? Well, it's x, of course. All right, so whenever the bases match, you just get the exponent. So now I'm going to get this. I'm going to get negative the log base 10 of 7.3 minus the exponent, negative 6. Okay, now I'm going to drop that base. So I'm just going to write negative the log 7.3 plus 6. And you know what? I just have a feeling they're going to ask us to go a little bit further. So what I've got here is this. Negative, you see this? Negative the log of 7.3. I'll go ahead and write the 6. But really, it says negative 1 times the log of 7.3 plus 6. Now, I've got a multiplier out here, and I know multipliers come up as exponents. Right? So now I get this. I'll do it up here to the right. I get the log of 7.3 to the negative 1 plus 6. But now this thing here, I can get rid of that exponent if I drop the base down. So I'll get the log of 1 over 7.3 plus 6. I just have a feeling this is what they're going to want us to do because I can't go any further with this. And that finishes up the first 5 problems in homework set 38.